thank and welcome the next speakers are coming along. And we got, I'm going to try here, mate. All right, there we go. I'll tell you a story about my Latin at school, so I was not happy. Jerry Makarawicz, Makarawicz, and Huxley Witt from Bryn Mawr Marine to give a discussion on lithium batteries. Thank you very much.
Can you find a hand for that on your pocket or somewhere? There's a little hook. That's great. Stick that. Fantastic. Okay. Hello, everybody. So let's get going on the batteries. So we're going to try to give you a little bit overview of lithium iron phosphate batteries. To start with, there is a lot of different lithium batteries, and generally when you hear the word lithium ion, but it really doesn't mean anything, because it could be the main ingredient. If the main ingredient in the lithium is different, then the battery is completely different. So we're going to talk a little bit about that. We're going to talk about the major differences between the regular batteries and the lithium batteries, the difference within the lithium batteries, and then on the last part we'll be talking about the Super B, which we represent, which is a lithium iron phosphate technology. So we basically all want the same thing from the batteries. Doesn't matter what kind of batteries they are. We want them to be safe, and we want them to be reliable, and we want them to live a long life, not be too heavy, so we don't need to fight with ADs dragging them over the shafts or stringers. And can the lithium batteries do it? For sure, they can do much better than the regular batteries. Why they can do it much better? To start with, the major differences will be weight. So to give you the idea, the average, let's say this green battery here, it's a 160 ampere hour battery, so it's equivalent to 1 AD battery or 2 golf carts. The weight of it is 68 pounds, which basically means 50% less than equivalent. Now, if you go to and that's a house power, right? The green one, right? If you go to cranking batteries, the orange battery on a table, the difference is 80% less. What Huxley is holding, it's a real battery, and it starts the big diesel. So it's 1,000 cold cranking amps on that battery, and the weight of it is under 10 pounds. So for sure, the weight is a huge difference, okay? The size, as you can see, is also a big difference because probably 8 of those will fit into 1 AD. Another very important thing is the voltage. So the major difference between lithium and regular batteries is that when you're charging or discharging, the voltage really doesn't change. The voltage basically remains the same unless you use 100% of the battery. Then it drops down like a rock. So now you need to have some kind of equipment to make sure that you catch it before it drops down. Because if it really goes down, then you cannot recover. So because of that, you basically have 100% of capacity available from lithium battery, where from regular battery, you will have 60 to 70 because the voltage will start to drop. Fast recharge, that's another big feature. You cannot recharge huge battery bank in 1 hour, but you can recharge in 1 hour lithium battery. You're gonna reduce the life of it, but if you have a problem, you can recharge the whole 160 amps in 1 hour if you have a charger big enough to do that. And of course, the last but not least is they are pretty much eco-friendly because there is no exhaust and there is no acid. The only thing that's in it is basically lithium salts and a piece of metal. Right? So here is what we were talking about, what happens to the voltage. So you can see in this particular case, don't worry about the 58 volts for whatever reason they decided to go with something that has a higher voltage. But basically the whole idea is to show you that practically to 100%, the voltage remains the same, where the blue, which represents acid battery, the voltage drops very quickly as you use it. And this shows you how much you use it extends or decreases the life of the battery. So the lower one is a typical AGM battery. So you can see that basically, if you use it 100%, you're barely going to get 200 cycles. Now, if you look at the 100% at the lithium, you get a 4,000 cycles. So the difference is huge. There is no really comparison between the two technologies at all. Now we're going to talk a little bit about the varieties, because like everybody says lithium ion, but actually there's so many different ions. So the most common that you see right now on the market are the 4 that you see here on the list. Basically, the difference is that each one uses different metal as an ingredient. So the iron phosphate obviously uses iron. The other ones use cobalt, manganese, and nickel. And there's a lot of advantage to it, but there's also disadvantages. So we're going to try to really, in very short here, try to give you some ideas about the differences between. So LCO, which is lithium cobalt oxide. In red, you can see disadvantages. It's a very popular battery. Pretty much everybody has it in a laptop and a phone. But thermal runaway is only 150 degrees Celsius, which means that if it gets that hot quickly, that's it. You can't control it. It's gone. And when the temperature goes to thousands, basically it melts itself. Number of cycles is not that great either, because it's 1,000 cycles where you will see a little bit later that the iron phosphate is doing much, much better. And the cobalt, there is not a lot of it around, and it's very expensive. This, the NMC, is used in cars, but not in Tesla. The next slide will show you which one the Tesla is using. So you can see that the thermal runaway here is much better, because now it's 210 degrees, which means it's going to burn. If it's going to burn, it's going to take much more to get it to burn. And the cycles are still not that great, but has a lot of power. In a small space, will be much more powerful than the iron phosphate. This is the one that Tesla uses. And in Teslas, I need to say that they work great. There's nothing wrong with them. But there is a danger, and they are water cooled. So if the cooling fails, then you have a major problem. If the cooling doesn't fail, then everything is fine. Right? Again, the cycles are not that great, but the punch that you get out of the battery is much bigger when you get it from the iron phosphate. That's why they're using it. They're just hoping simply there is no accidents. So far, they didn't have too many. So, and this is now doesn't matter what readings you're gonna do, and there's a lot of interesting readings. If you're interested in reading more about the batteries, there is a website called Battery University. It's a company that builds battery chargers, and they go through testing every possible battery on the market, including different lithium batteries, and on the end, they tell you what they think. And their conclusion is, again, that if they were to use for anything the lithium battery, they would use the iron phosphate technology. So thermal runaway, as you can see, is huge, 270 degrees. So the battery needs to get very, very hot before finally takes off. The cycles, the cycles are 2,000 or more. So it's practically double compared to all the other batteries. This thing here is really basically the same thing that we talk about it, just it's shown in one graph where you have all three next to each other. Here is the interesting, and that's where you can see that the other technologies outpace the lithium phosphate. Lithium phosphate is just barely in the middle here. And you can see that if it comes to density, those other technologies beat them by a mile. So again, much smaller package gives you much more power if you go to cobalt or to magnesium. Now, thanks enough that right now, the difference starts to get a little bit smaller. This graph shows you the most common marine power banks in lithium. And basically, there's 3 different companies that right now have a lot of batteries around. Definitely the biggest company in the world is Corvus, and it's a local company. And they have over 120 projects where they have actually their batteries doing electric propulsion. So the Corvus is definitely #1 in the world as far as application right now for lithium batteries. The The other company is from, the other two are from Holland. Super B is from Holland, and the Flowtech is also from Holland. So you can see that now this new product, that Nomada, actually starts to come close to everybody else. So basically now they caught up with all those guys here. They are still below the Delphin model, which just has even more density. So this is what happens when you start to compare the lithium, and if you don't talk about how small it is and how powerful it is, then you start to talk about safeties. And as far as the safeties are concerned, really there's no comparison. The phosphate is way ahead of everybody. Here are the graphs to show you partially why. So you can see what happens if the battery takes off, and you can see the phosphate on the left drawing. The iron phosphate is in red, so you can see the difference in temperatures when the cobalt, for example, takes off. And the same thing here. So definitely, if you ever think about it, there is very little venting, but they still found a graph that's even less on iron phosphate than the other batteries. The thermal runaway, it's a big problem from point of view that because those batteries have magnesium and cobalt, when the magnesium or cobalt burns, it produces the oxygen. So basically, there's no stopping of that fire. When that fire takes off, you basically need to let it burn off, because there's no way you're gonna easily put it down. That's what this represents. The interesting thing is that the lithium iron phosphate is not like that. There's a little slide here to show you when the battery was originally developed. They want to really know what happens, so they force it actually. Oops, what happened here? They force it on fire to see what happens when the iron phosphate is burning. And they were very pleased with the results. Of course, this was done under very safe conditions. They called the fire department. They had a special room away from everybody else, just in case if it explodes. And that's a 160 battery. That's the one that's here on the floor. So far, this is the only one right now that has marine approvals. It has ABS certification. And the only one stipulation now is, as you know, the lithium batteries are relatively new to the surveyors. So we are not sure exactly what to do with them yet. So right now, the ABS decided they don't want that battery in a wellhouse. Like very often, for example, emergency batteries may end up in a wellhouse. Well, they don't want them in a wellhouse. Why? Well, they said they are not sure if the BMS, the battery monitoring system, does not interfere with navigation light equipment. From our own experience, we know that it doesn't, because we did test in the harbor. We put two emergency batteries in a wellhouse, and they're running now for 3 months, and there is no interference with equipment. So the BMS doesn't. As far as possibility of explosion, I will explain to you a little bit later. With that battery, it's not possible that that battery explodes. So now he has the two burners going. The whole thing, they speed it up because otherwise it's really too boring. You know? But the whole process probably took less than 8 minutes. And basically after 3 or 4 minutes, the battery was fully engaged. And you can see the plastic is dripping. And basically the stuff that's falling down right now is just a plastic casing that's melting. Yeah, you can just, yeah. So after a few minutes, they stop the nozzles and they just let it burn. You can see all this plastic is dripping. But even after all that fire, you can still see actually the cells. I didn't tell you that yet. Maybe that's time to tell you now that the basic lithium battery has less cells than acid battery. So the voltage is pretty much the same. Instead of 12, it's about 13.2, but there's only 4 cells producing the same voltage. So because of that, obviously, each cell has a higher voltage. There is a separation between the cells to make sure. You can see now the shape. basically one cell got a real beating, but the other three are still standing. Now he was so quick that he didn't even bother to look. As he was walking away, the fire restarted. So he came back and put it down, but he doesn't have anything. He has no chemicals in his nozzle. It's strictly water. And that's the biggest difference of an iron phosphate versus anything else, as far as the lithium is concerned. So now we're going to talk a little bit more about Super B itself. Those things that you see on the screen, we basically talk about it. The weight and the size, the constant voltage. One thing we didn't talk about it is integrated battery management system. So in case of different companies do it different ways. In case of Super B, each battery comes with its own computer. So on the top of the battery, actually, there is a computer. And the way you hook up the lithium battery is you hook up the computer to a solenoid, and all your charging and discharging is after the solenoid. So basically, computer controls the solenoid. If the computer decides that any of the factors is no good, it turns off the solenoid to prevent the battery from being damaged. Now, what factors they are? They are mostly going to be voltage, current. You will see just in a second further down. So another thing other than a BMS, no cooling or special firefighting required. Charging, you don't need to change the charger if your charger is reasonably new. Most of the chargers for last, I don't know, 5, 6, 7 years, they will have already AGM mode on it. And if your charger has an AGM mode, then you can charge this particular lithium with AGM. You don't need to change to a lithium charger. The curve, the charging curve, is actually very similar. This is the charging curve, and the red represents what happens with the voltage, and blue represents the current. So to give you an idea, basically, if you hook up that battery is 160 ampere hour, let's say it was practically fully discharged, you hook up the 60 amp charger to it, what happens, the current become constant and the voltage keep rising. The voltage keep rising till about 14.3, 14.4. Then at that point, the current tempers off and the voltage drop down, and eventually the voltage end up at full battery somewhere at 13.5, pretty much similar to regular acid batteries. This is the picture. So you can see actually the computer on the top. And now you can see what the BMS does. So the way the BMS is probably the best part of that battery. The Dutch engineers actually did a really good job designing the BMS. So for example, if you look at the charging voltage, if the voltage is above 4.5 volt, the computer turns the charging off. Well, not the charging, but the solenoid, which automatically will turn the charging off, right? Now they're saying direct, but what they mean is instant, right? So if the voltage is 13.8 per cell, then after 10 minutes, it will shut down. If it's 4.2, then 10 seconds, and if it's 4.5, instantly. The charge current, the C, I don't know, for some of you who may not know, C basically means full capacity. So in case of this battery, 1C means 160 amps, okay? So if you're gonna charge it with 160 amps, after 15 seconds, it wants to shut down. It doesn't really like it. Now you could bypass that, and then if you are in absolute emergency and charge it anyway, but you're gonna reduce the life of the battery. Instead of maybe 5,000 cycles, you may end up with 3,000 cycles. The temperature, and that's a very important one because basically this what will prevent your battery from burning. There are 7 temperature sensors inside the battery. So the fuse and the shunt have a sensor, the case itself has a sensor, and every cell has a sensor attached to a cell. There's no way that the battery is burning. That's just not gonna happen. When the temperature goes up, the computer shuts down the battery. And we know that now, we never had a situation yet that we had a fire on the battery, but we had a situation where there was a small batch of faulty temperature switches, and it shut down the battery, saying that it's 80 degrees, even there was no 80 degrees. Turned out to be that they had a bad day in the factory, and the switches were a problem. So right now, basically, the Super B makes house batteries from 90 to 210. BMS is available from 100. The reason that it's that 90, but it's only 100, because there's one style of a battery for a motorhome that does not have a BMS in it. That's why it says from 90 to 210, but BMS only from 100. And the starting batteries that can do from 100 amps up to 1,000 amps, like the one on the table. This is the typical, this is their best up till now. This year they have new products, but up till now, this was their best battery. And this is the one that we talked to about differences in weight and size to other batteries. This is a starting battery, the one that's on the table. So one thing to notice is that about the starting batteries is that till the new battery comes up, this battery is so small that doesn't have a BMS. So that battery cannot protect itself. So in theory, if you don't find a way to protect that battery in some way is danger battery, because if you really mistreat it, it's gonna blow up. It has no way of protecting itself. So right now, we had one situation like that actually, where we had a huge mega yacht that pushes, I think altogether about 30 different batteries, including 2 of those for each generator, 2 of those for each main engine. They decided not to drive the boat to Florida, but put it on the top of a ship, and the ship will take it to Florida. On a ship, this special ship has a provision. You can actually plug the boat and you can charge it. Well, they decided not to do it. And then one of them decided in the middle of a trip to start the engines. So he went and pressed the button, and the batteries just went poof, and that was the end of the batteries. So thousands of dollars was destroyed. There was a big discussion with Super B, and the Super B said, okay, it's our fault. We should never sold you the way like this, because we didn't expect it that you're going to mistreat the battery that way. So we'll replace it all free of charge. But from now on, we won't sell that battery in that kind of scenario anymore unless there is some kind of protection. So up till now, what Huxley has in her hand is over-under voltage relay. And what you do is basically wire this relay in series with the battery. And if the voltage is too low or too high, it won't allow you to crank. Because the battery is the most danger, any battery, including the acid battery, is the most danger when you're putting a huge load on it. And it was not maintained before that. In this case, there is no maintenance, but it should have shut down on a low voltage if it had a device to do that. The new battery, which is coming later this year, has already BMS in it. So the moment that new battery is on the market, we don't need to worry about it. But up till now, we sell this with a voltage relay, and we also sell it with a current relay, because as you can see on a graph there, that battery should not be getting more than 77 amps, and very often the alternator is much bigger than that. So we're putting a charger relay, and then if the alternator is trying to charge at 100 amps, that relay will shut off and prevent that battery from getting 100 amps. Now, talking about the explosion, the regular batteries will explode the same way. My background is marine electrician. I spent many years deep sea. After that, I had my own company. So I can tell you from my experience, there is a charter boat down in the harbor, and it's a small boat. It's about 40 feet. It has a bow thruster because it's a flat bottom, so it's easier to maneuver with the bow thruster. The owner is older and never really had enough energy to look after the boat. So one day, he decides to take off, and it's hard to get out, so he's using bow thruster. He heard this big bang, and he didn't know what it was. But after this big bang, the bow thruster didn't work anymore. So he phones me and says, I have a big government charter. You better come and have a look, because I have no bow thruster. So the bow thruster was together with batteries and a charger in the forward compartment. When we opened the hatch, 4 golf carts were gone. The only thing was left was the bottom of the golf cart. They completely disappeared inside the compartment, they got completely blown up to little pieces. The batteries had no water, and he put a 800 amps load on it. Right? So it doesn't need to be a lithium battery to do that. So another thing here that I didn't mention yet, which is really worth mentioning, is cold temperature and lithium. They will operate in a cold temperature, but you cannot charge them in a cold temperature, which creates a problem. The lithium will change the consistency if you expose it to temperatures below 0. So right now, unfortunately, we don't have a solution to it because the BMS is not able to detect the low temperature. It's able to detect the high temperature, but not the low temperature. So if you had those batteries somewhere where it's in an extreme Arctic, for example, and the compartment inside gets to -10, you can't charge it. You need to disable the charger, or you need to take the batteries out, put them somewhere where it's warm enough that they can be charged. If you try to charge them in below temperatures, they will basically give up and it will be the end of the batteries. But you can use them up to -25. So if you, let's say, have 2 batteries and they are not that heavy, you can use it when you need it, but then you need to pick it up, take it inside, warm it up a little bit, and then you can charge it. Right? Well, we had one project, it never actually materialized, but we had one project where they designed a ferry, passenger ferry up in Northwest Territories. And that ferry had no generator. It only had batteries. They decided the whole ferry based on a whole bunch of those batteries. And they decided to put them on a deck outside. So they said that the ferry doesn't run for 4 hours, but nobody was able to tell us. In 4 hours, can the battery temperature drop to below 0? Once it happened, we didn't need to worry about it because at that point, that battery had no approvals. It took a long time to get them, and the government decided they're not going to wait for the approvals. They just went to regular technology. So we never found out. This is a little bit about, if you remember that graph that showed that one battery that's catching up with those other technologies, this is the one. And what you see here is actually 3 of them together. The way they are designed is you don't need a cable. So you can actually get those metal bars and you can hook as many of them as you want to. And the top here is for the communication. So the communication cable. Same thing with this battery. It can again operate in minus, but cannot be recharged. That will apply pretty much to any lithium battery. This is the 210. Really, the only difference between those two is that this is 160, this is 210, but the weight went down. The other 210 was 68. This is about 46. So you basically go down 20 pounds and you get another 50 ampere hours, right? This is the new smart charge. It's supposed to be available later this year. So this one already has BMS, and this one will unhook itself if it sees the problem. Here is just a tiny bit very short about Super B. It's a little bit interesting. The fellow who originally started the company he really loved to race motorcycles. And he did himself Dakar races on a motorcycle. Because he had 2 engineering degrees, he decided to develop battery that he can actually use on his motorcycle. So he developed the orange battery. And he did the Dakar race on that orange battery. The people looked at it and says, well, if you can do it for a motorcycle, why don't you do it for the car? He says, well, basically that can do the car too. So they start to put, and right now, any luxury brands come with an option of a Super B battery in it. Now he's not around anymore, but the company grew when they started. There was 8 of them. Now there is 120 engineers working on projects. They are in Hengelo. Hengelo is about 1 hour east from Amsterdam. So here are the projects. I will tell you a little bit more when we go through the first one is a local ferry. The second one is a Danish ferry. That second one, as you can see, it's house loads. It's not electric propulsion. The first one is not electric propulsion either. The third one is the Taiwanese ferry. The tug is electric propulsion, but not used a lot. It's mostly diesel electric now. Then there's a couple of river boats. And that one here on this picture is still a restaurant only. Now this one here is interesting because that one and this one on the bottom right now operate in Amsterdam on the canals, and they are fully electric. So they have 99 batteries. So this is Tachik. Tachik is a pretty old ferry. It runs out of Quadra Island, Cortez. So basically it runs 365 days a year, 12 hours every day. So what happened is they didn't have enough money to buy the new ferry, so they needed to do something. So they repowered that ferry. They put in much more efficient generators, but the generators that they put on run off the clutch of the main engines. So when the ferry slows down to dock, the speed of the generators goes so low that it's enough power for the household load, but not enough for a huge bow thruster to guide the ferry into the dock. So what they had originally was a massive 800 horsepower diesel that will run basically 12 hours, and they use it every hour for 2 minutes. Right? So you can imagine how much fuel that cost. So somebody said, well, there must be a better ways. So they designed a battery bank, 54 of those batteries. So that's a 750 volt DC system. That goes to regular inverter, who converts it to three-phase 440 volts AC, and that goes to the bow thruster. So basically, those batteries come on every hour for a couple of minutes. Right now, that project is about 8 years. 5% of capacity of the batteries was used so far. So those batteries basically will last there forever on that kind of project. And the fuel savings were so big that in 3 years, they paid for installing the batteries, inverters, and everything. Yes?
How are they charged?
The inverter reverses. When the engine goes full speed, the inverter reverses, becomes a battery charger. So the charging is good. It's a good question. Charging is a little bit complicated from a point of view. There's 54 of them in series. And how do you, it's very interesting actually how the balancing is done. How do you charge 54 batteries? They are not identical. The charge needs to go through every one of them because they are in series. So it's actually very interesting. And through this process, we found out actually that the software had some faults and needed to be changed. So what happened is when they designed this, the ferry runs 12 hours a day, every day, so everything was great. But then one day they decided they need to go to do repairs, and they're gonna run for 40 hours to get back to the shipyard. Well, nobody ever designed the system to run for 40 hours. So they found out after 35 hours that the battery is getting too much charge, and the voltage starts to go up on the batteries. Because what originally happened was this. Let's say those batteries are numbered from 11 to 54 to 64. And let's say battery 50 says, excuse me, I'm already fully charged. I don't want any charge. Well, that charge still needs to go through that battery to go to all the ones that are behind it. So the system says, okay, you don't want to have 50 amps? We're going to reduce it to 3 amps. So now the 50 amps drops to 3 amps. The battery that says I'm fully charged has a special resistor that 3 amps gets redirected to that resistor and basically converted into a heat and wasted, where the rest of it passes through to other batteries. Eventually, because they are all very close to each other, within 2 hours, they are full charge again. Right? And the same thing repeats itself over and over and over. But what happened on that 40-hour run, it turned out to be that 3 amps is too much. After 40 hours, 3 amps, the resistor is so hot that the battery voltage starts to rise. So they redesigned the software to 2 amps. When we did a lot of tests on 2 amps, it turned out to be that 2 amps is big enough. After 40 hours of running, the voltage did not go up. It stayed where it's supposed to be. This is the canal boats. So in Amsterdam, they passed the law that by 2025, you cannot have anything in a canal that pollutes. So you cannot have a gasoline engines, you cannot have a diesel engines, nothing. So the only thing left is electric. So all those tour operators now converting in a big hurry to electric boats. So this was the first one. They use 99 batteries, and they basically use them also as a ballast. So they put them in the villages. They can be in any position. There's nothing liquid there. So you can put them upside down or sideways, whatever. They don't care. As long as you can have access to the wiring, basically. Right? This is the Danish ferry, but the Danish ferry has only household loads and the big inverters. This is, I think this is 2 or 3 years old project. This is our old Vector. That's one of the oldest Coast Guard ships. What's interesting about that ship is that it has no emergency generator. So they are really concerned about the emergency power, because if the generator goes, they have nothing unless the batteries can provide the power. So on the top of the house, they have 11 8D batteries, 1,000 pounds of weight, which really bother them. So they came and says, what can you do to reduce the weight? So he says, well, we can put those and we can reduce the weight by 50%. So they said, okay, but we have some very important loads here that basically cannot go off. So that was a little bit more difficult, because how you do this. So what we did is, imagine 24-volt bank. So basically you have 2 batteries, right? But we start to worry what happens with, capacity-wise, 2 of those batteries is plenty. But we start to worry what happens if 1 battery fails, they have nothing left. So instead of 2 batteries, now we have 4 batteries. Each of them has its own solenoid. So there is 1 solenoid for 2 and another solenoid for another 2. In a normal operation, all 4 are on the same load. But if something happened to one of them, 2 go off, but the other 2 stay, because now they have an independent solenoid, right? So this way, their capacity goes down by 50%, but they still have power. And those 2 that we're talking about is very special radios. Without those radios, they cannot operate. This is the Mucho Mas. This is the one that had explosion, actually. This is the one that was taken. I mean, explosion wasn't such that there was no fire or anything in the engine room, because they were closed in the boxes. But they basically broke into pieces, those orange batteries. Right? This is the latest project. It's a very difficult project, and I wish that we never started that. That's our police boat in the harbor. The environment is horrible, because that compartment here that you see, it's open on both sides with scuppers. And when the engines, they have like 400 horsepower, 2 engines on the deck. So when they go really fast, the water comes into that compartment. So I didn't expect that it's going to be that much water that battery exposed to. The battery by no means is waterproof. It's not made really to be in that kind of environment. So what happened, the first battery failed after a month. That's it, the water got inside. Right? So, you know, the compartment is so tight, there's no really way to build another box that you can close it all up. Plus another problem was, they go 30, 40 miles an hour in this boat. The boat keeps pounding. And doesn't matter what brackets we build, they will break, they get loose, the batteries start to jump up and down. I mean, I just never expected when we started it. I thought they use it once in a while, they use it every day. Right? So what happens is the second battery, we said, well, we can't, you know, so we end up, this black stuff that you see is electrical liquid tape. And Teflon based, right? You can buy it at Western Marine. It's very good to protect something from salt water. If you put enough coats, the water does not get through it. That's it. The plastic hardens. And so the second battery, it's all covered in this. And we went after 3 months to check, the water did not get in. Right? So right now the water being kept away from the battery. And behind this battery, which you cannot see, there is 2 of those guys for the 2 large engines. Right? And those guys really doing great. They have the voltage relays on them. So if the voltage goes down, they can charge, which is good, because sometimes they are not really terribly technical people. So you need to have something that helps them. So they also have energy monitor, which I think for most of the people using large amounts of battery power is a must. Energy monitor, basically, it's a device that measures the voltage, the current, and the capacity, and calculates the difference between what's going in and what's going out, and displays you the difference so you know what anything draws, you know how much power you have left. If you're gonna use that much power, you know how long before the battery is gonna be dead. So they have one of those, and that helps them a lot because now they know what's going on with the batteries. They can see the charge on it, they can see the discharge, and you can learn from this also how much each piece of equipment in your boat draws. Because what you can do is you can turn everything off, turn one thing on, it shows minus 5.6, means that this particular piece of equipment draws 5.6 amps. This was a first project, how we all started with this thing. So what happened a few years back, the fellow came and said they're doing the race for the environment in Vancouver, and they need to run some lights and a generator, but the city told them they cannot use the generator. If it's an environmental race, how could they use the generator? So they need to have a quiet power. So on a piece of plywood, we put this 160 and an inverter. I gave them this piece of plywood because, I mean, I had 2 days. So basically wired the inverter to the battery on a piece of plywood, right? They used it all day. They came back and said, hey, that worked great, but can you make a nice package out of it? So we designed boxes like this. And the fellow showed up and says, I'm buying those boxes and I'm gonna have a rental company. Now he has a company that basically rents for the events, quiet power. So this particular box has a 160 ampere hour battery, has a 2000 watt inverter with a 55 amp battery charger, has a very sophisticated MPPT solar controller, so you can hook up to 10 solar panels to it. And depending what you draw, you can spend a few hours on a clean power. That's it. So if you have any questions, you're welcome. If you want to see pieces closer, you're welcome to come and have a look. Oh yeah, okay, that's right. We didn't do this yet. So because the battery is pretty expensive, you're looking at about $2,300 for this particular battery. The advantage is that you have ability to go inside the battery and see everything that's going on with that battery. The battery has an internal log. So if you, let's say, did something to it, like massive overcharging or it will show up. You just go to the log and it will come. So this is your second screen. And the second screen right now breaks that battery down to each cell. You can see whatever the lowest or the highest voltage. You can see all the temperature sensors. So as you can see, you have fuse, case, shunt, plus you have a sensor on each cell. So really, and you can see the history here, right? So if the battery was overcharged or under voltage, it's going to show up there. You can see, for example, this value here. What happens when they fly those batteries? They need to discharge them 70%. So that 200 amps was put on a battery load to discharge it to 30% so it can be flown. You can fly them, but there are restrictions, right? The battery is supposed to be new. It cannot be used because they're afraid that something can happen if the battery is used. And you need to discharge it 70%. Yeah.
One question. In relation to, let's say, lead acid.
Yes.
We know that there's a curve where it falls off about 10 and a half to 11
Yeah.
volts.
Yeah.
In this case, you get the full potential of the battery.
Yeah, it doesn't fall off at all.
12.5.
Yes. Yes.
But you said that's 70%. So in relation to the 8D battery, would we get a longer cycle out of this?
Of course, this will give you approximately 5,000 cycles.
We're going to that point where the fridge is going to quit at 10.5.
Well, this is not going to quit. No.
But in the same respect, if I got, let's say, 2 days of an AC battery, what would I get out of this?
Okay, well, let's do it this way because that will be easier. Let's just say for a figure of speech that our load is 5 amps. Okay, so 160 divided by 5 will be 32. So basically, if the fridge was to run every hour, you will get 32 hours.
So it's an easy 50% more.
Oh yeah, for sure.
And
Yeah.
this would have the automatic cutout in it, and it's just going to.
Well, it has a computer, and then what we do is we hook up solenoid to it, and the computer talks to the solenoid.
Now, when you say this battery goes dead, it's finished. You can't recharge it.
No, so basically, I don't know for sure if the engineers know exactly at which point of the voltage the battery is finished. I don't know that because we had a different scenarios going on. At first, okay, let's put it this: the BMS shuts it down at 8 volts. So as far as the BMS is concerned, you should not go below 8 volts. Now, what happens if you do somehow? Well, the solution is simple. The battery is not at that point damaged at all, but you cannot recharge it right away with a large charger. You bring a little guy like this, who basically maximum can produce is 5 amps. And this guy starts with a half an amp, and then goes 1 amp. And you basically keep this one on till the voltage satisfies you, let's say 10 volts. Then you unhook it, you hook it to a big battery charger, and you're done.
No different than a normal tracing.
Yes. Now, we don't know still for sure at what exactly voltage the battery cannot be recovered. I can tell you that we had a really bad experience with, when we sold those batteries to this, I told you about the project up in Arctic that was canceled. So what happens is they phoned me, they said, sorry, the government canceled the project because they're not gonna wait 6 months for Lloyds to approve the battery. We're sending the batteries back. We realized that we're gonna pay restoring fees, whatever. We're sending the batteries back. So the batteries came back and went on a shelf. Well, before that, what happened is, before that, the battery did not have a BMS. If the battery doesn't have a BMS, you can put it on a shelf 2 years later. The difference in voltage is 0.1 of a volt. The lithium basically on its own doesn't lose the voltage. It loses it in such a slow pace that 3 years later you can use that battery without recharging. But the BMS made a hell of a difference. Now BMS can kill that battery in 3 months. Well, up to 0.7 amps because he also needs to hold the solenoid, right? So now what happens is if you leave that battery unhooked, BMS is hooked up but no charger, 3 months the battery is dead. So that's what happened with 17 batteries on a shelf. Nobody told me about that. That now we put a BMS, you need to recharge it every 3 months. So they sit for 6 months. And the customer shows up and says, hey, I need 18 batteries. Well, great, that's what I have on my shelf. So we go, we recharge it. We put a 60 amp charge, which we should never do if we were told about it, that we should put a 1 amp charge to get that voltage up, right? So we put a 60 amp charge. They're all fully charged, they show up great. Except that if you go through the whole history, you can see that the voltage went down to 2 volts on a cell. So I contacted the people who designed the battery, and they say, well, we don't know. We really, truly, we don't know. Let's hope they're gonna be okay. Well, they were not okay. They start to produce some really strange alarms. So what happened, put 18 of them on a boat. 3 days later, the guy phoned me, he says, there's a problem. I says, what's the problem? He says, I don't know, but the battery is not working. So we go check the 18 batteries. 7 of them say high temperature. We tested it, there's no high temperature, but 7 fail on a high temperature. So they think that the lithium consistency changed because the voltage gets so low, and that created faulty reading of temperature. So really for sure, they don't know if that value is 6 or 5 or 4. But at some point, the battery cannot be recovered if it gets that low. No. No. Well, that battery, it's about $2,400. The orange one, it's about $1,100. Right? So, you know, from the practical point of view, if you try to compare the cheapest possible golf carts, then there's no comparison. You can buy 2 golf carts for $300. This is $2,400, right?
The price point, I use the Magnum Energy one.
Yeah.
Price point is probably $1,000 more for that one.
Right.
But I would mean in my boat, I just load it with more garbage.
Mm-hmm.
Half the weight.
Yeah, that's right. So we know that this from the Tachik, we know that those batteries can last very long time. The manufacturer thinks that basically you can get 15 years out of it because the battery looks after itself. You don't need to do nothing. If the battery thinks there's a problem, it shuts down the solenoid. So realistically, nothing should happen to that battery.
Now, there was no access. I know some of the earlier models, one of the issues was if you tried to have one of these cells midway, you'd blow up the battery. Here, there's no chance of doing that sealed within the case.
Yes, yes, yes. I mean, you can take the case apart when you have access to the, but I mean, why would you do that, right? They are not. Yeah. Well, we had on the Tachik, we didn't have problem with batteries, but we had some other problems. You wanna see that, if you find that picture where the Tachik, all those cables are hanging? Oh, right there. So see, look at this. So this is the 54 batteries, but they need to talk to each other and to the engine room. So they all require a communication cable. So what happens, from every battery comes a communication cable. It goes to a T, from the T splits to battery before to the battery after. And there's basically 54 batteries, there's 2 strings of 27 batteries. The biggest problem now is the actually communication cables. They're breaking down. They were not developed for boat that vibrates, and every 2 years, 3 years, we have a problem, the batteries came out. What happened? Well, we start to trace and we find the bad cable, so we change the cable. So now we got to the point that we get so tired of it that we try to get custom-made communication cables. So I'm still waiting for a price for somebody to make particular length custom-made cable. Those ones are cheap. Those ones are like $8, but they break every 2-3 years. No, no. I mean, as it is with this, it's complicated. With the Bluetooth, will be just. And the ferry travels in a really bad spot too. Most of the trip, there is nothing on a ferry. They do have satellite phone, so they can use it. But for us, every time we go, it's a nightmare because we cannot. The Super B through the program that I have on a computer has ability to go into the battery and through my computer to look at the battery and make some suggestions that maybe I cannot make. But you need to have access to the internet. So if there's easy access to the internet, I go to my computer, we go to a TeamViewer, and through TeamViewer, they hook up to my computer, they go inside the battery, they go to the dedicated log, and they can tell much more than I can. But if you have no internet, my phone doesn't even work most of the places there. So it just, it's difficult. And when it's so many of them talking to each other, it's even more difficult. Because what happens is 27, it's a one battery bank, kind of. 27 is the other. They come to the big communication cable. Then they go to the device called a repeater. It takes those 2 signals, converts it to one, sends it to the engine room computer. That's actually the weakest link in that whole thing is those cables.
So if I were using, let's say, 3 of those
Yes.
in an application, I would have to link them with that cable you had, so they're all, one is not charging more than the other.
Yes,
So
yes.
they'd be a single identity.
Yes, yes, yes.
Can you use the battery isolator on?
I wouldn't. But are you trying to find if you can charge to different sources? Well, you know, the lithium is so different that they don't even recommend to charge this one and that one from the same source. So what we normally do is we would have alternators. So for example, on a police boat, the 2 engines have 2 alternators. One alternator is charging those. One alternator is charging those. There's a common battery charger that they plug in, and that one output goes to here, one output goes to here, and then one goes to there, right? But the charger has already isolation built inside anyway, right? But the diode isolators, I mean, my background is marine electrician. Diode isolators is not the best way of splitting the charge. I think charging relays is a much better way of doing that.
What I understand is a single identity with three of them together. I could use my Magnum inverter charger to charge them as a group of three.
Yeah.
And when I'm underway, my Baltimore alternator with a smart charge is going to carry
Yes.
on the same, and then you can just carry on
Yes.
charging the start battery.
Yes. Yes. Go ahead.
What's your opinion of these new Firefly carbon?
You know, in every presentation that I go now, I get that question, and the answer is always the same. I don't know enough to have opinion. I have only one customer who has it in Boradia Club here, and they have it for 2 years, so it's not enough time. I mean, they are not cheap. Little bit less, but you know, that's what I was trying to say when I started about those two golf carts. There's basically two ways of, you cannot compare this to the two cheapest golf carts because there is no comparison. But if you, let's say, go to AGM battery, that battery now, one golf cart may cost you $300–400, right? So now you have $800 already versus this, right? And if you're gonna change them twice in a life of this, which 9 times out of 10, that's what's gonna happen. They're not gonna last as long as this battery gonna last. Because there is nothing in this battery basically that can go wrong. There's so much more can go wrong in a regular acid battery. You can get a cell contamination. One cell goes, bing. Here, because of that BMS, you wouldn't believe it if you go back to looking at the battery. You wouldn't believe how close the voltage of the cell gets, within a 1,000 of a volt. That's how close the cells get to each other because of, well, 4,000 of a volt here, okay, the biggest difference, right? 4,000 of a volt, when a normal battery could be 0.1 or 0.2 volts, right? So the, yeah.
If I could interject the Firefly, the carbon foam, I think it is, I think the main advantage of the carbon foam is that it can be left alone for a long time, whereas lithium also can do that without BMS.
But not with BMS, no.
Yeah, exactly.
So on a boat, you cannot just turn the charger off and go away. And of course, the charger is smart enough and the battery is smart enough that there is no situation why you need to turn the charger off. Because the battery, if it's fully charged, it's fully charged. There's no place for the current to go to. Yeah, yeah.
The electronic package in there, does it have a UL approval to be in an explosive environment?
The battery itself has ABS. ABS, American Bureau of Shipping, classification company, right? So, and the only speculation in that approval certificate is they advise not to put it in a wellhouse. So then the question is, well, why can't you put it in a wellhouse? Well, they say, well, you know, if the battery explodes, do you want a battery explode under the dash? But that battery is not gonna explode. Well, what about the interference with communication? Right now, we don't have any proof that there is one. There is one boat in a harbor that has 2 of them under the dash for 2 years now. They don't have any problem with communication. So obviously the BMS is not interfering with the radios. And I mean, you can go into LEDs and you can have a lot of interference from LEDs now, right, for that matter. Right? Well, this is a dangerous good. So because of that, it has already dangerous good certification and approval as a dangerous good. So this battery, no. And it is anyway, because basically there's nothing here other than a solenoid, right? The solenoid is not, well, I mean, the coils are sealed. So really the only thing you have is a contact, right? But the switching mechanism inside is not able to spark outside because it's basically a blob, right? There's another interesting application that I forget to mention. So those batteries are basically house batteries. So I got an inquiry from a fellow with a sailing catamaran, and he says he doesn't want to have a different house batteries and different starting batteries. He wants to use those batteries to start the engine. So is that a problem? Not really, because as far as the ability to crank, that battery can produce 1600 amps. So it can produce actually more amps than this battery. The problem is you need to find a solenoid that can take that kind of current, because this solenoid can take 1600 amps. If you're going to start the diesel with it, you're going to melt that solenoid. After that, the battery has no protection anymore. So what we end up doing is we end up putting 3 batteries and 3 solenoids to split that starting current into 3. So basically you have 3 batteries, 3 solenoids, common output from all 3. But now that current, instead of being 1600 amps, is only 1600 divided by 3, providing that every wire has the same length, right? And that works. Actually, on that catamaran, this is just an example. On the catamaran, the engine is only, I think, 200 horse. So the actual current is probably not more than maybe 200 amps when it's cranking per battery. But the solenoid that we use there, which we don't have here, I guess the plug-in solenoid, we don't have the one. Because there is another type of a solenoid which is even better than this from point of view that it's what's called B-stable solenoid. And B-stable solenoid means that it's on without power. And you only activate it to disengage the solenoid. So that B-stable solenoid, when it's on, doesn't draw anything. But the problem is the contact is maximum 150 amps. So on that catamaran, 150 amps was not enough. So that's why we put 3 of them. And right now, basically, that 600 amp splits in 3 ways, and that's enough, right? The solenoid is able to take that. That's it.
I have a strange question.
Yes.
This technology, is a lot of it coming out of Vancouver?
Uh,
You mentioned Corvus.
Corvus, yeah, Corvus is definitely out of Vancouver.
Why around the
I don't know. I mean, ours is not from here. We are here, but ours is from Holland, right? I don't know really why. I guess it happens to be a group of people really interested in developing that kind of product that got together and created Corvus. Corvus is doing great and is doing primary great in Scandinavia. That's where most of their projects are. One thing I should mention, which so far we didn't say, is that as far as the electrification of the fleet is concerned, that's a very difficult thing. The batteries, to be really honest, the batteries are not there yet. Because the problem is the customers have unreasonable expectation. We basically getting now huge amount of inquiries that we need to review and send to engineering at Super B, where they want to have electric ferries, but they want to go 25 knots. They want to sit at the dock for 20 minutes. Well, the only way this whole electrification works is if you can discharge as much as you can recharge when you're sitting at the dock. So if you're using 50% of capacity to make one trip, you better be able to recharge 50% of capacity when you're sitting at the dock. Otherwise, on 2 trips, you already lost 50% of your capacity. At 3rd trip, you are dead. And where the big difference is, if you go 5 knots, the use of energy is minimal. You go 25 knots, the batteries last 45 minutes, and they are gone. So there's a big difference between 5 knots and 25 knots. There's in front of the Bayshore, there is in the summer, one of the companies that has buses with tours, they have 2 boats with electric propulsion. And they're doing great. They take up to 10 people, paddle around the harbor, but they never exceed 5 knots. Those boats in Amsterdam that you saw in the picture, they go 5 knots maximum. So they last, the 99 batteries at 5 knots last all day. They don't need to recharge it when they change the passengers. They only recharge it overnight. But if you went 25 knots, those batteries will be gone in 45 minutes. Now, what would you do then, all right? So unfortunately, right now, the technology is not there. So the projects that are happening is the runs are short and recharging. We just did, the Super B just did one project for 2 passenger ferries. To go 25 knots, the distance that they wanted, it will take 1,800 batteries. 1,800 batteries. And then when you come to the dock, you better have an electrical power plant there, because you're going to be using like millions of watts of power to try to stick it back into the battery before the boat leaves. Right? So I think right now where really there is a space is for hybrids. There's a ton of space and a very good use for hybrids. But pure electric, unless you're willing to go 5 knots, there is not a lot of projects right now that are feasible from point of view cost. And another thing is, even if they found a way, if everybody was using half of the megawatt of power on the dock to charge the batteries, there would be no power. Even if you look at the electric cars, the fast charger takes 40 amps. So it's equivalent to your stove. So everybody comes home now, turns the stove, plus turns another stove to charge the battery. Usage of electricity will be incredible if everybody today had an electric car.